Hi, welcome to Ask Less. What is happening when a vortex tube does not work? I have a vortex tube in my hand, a medium-sized vortex tube. What a vortex tube does is it takes compressed air in, spins it one way, and then spins it back inside itself. This gets creates a heat separation. You end up getting hot air going out the hot end, cold air going up the cold end. And you can get down to -40, -50 degrees Celsius with a vortex tube. But what happens if it's not working like it's supposed to? There are several things to check. First of all, back pressure. Vortex tube is used for spot cooling. And normally you attach something to the end of it. You can attach a tube, attach a pipe, attach a flexible hose, depending on the application. But if that hose is too small, or there's a lot of restrictions, perhaps it's too far, there's a lot of coils in the delivery, and you create a back pressure on the unit, it's going to affect the performance. You create a back pressure, you start pushing the air out the other end. Similarly, if you have too much of a back pressure at the hot end, you could be forcing more air out the cold end. And what happens is, as you vary the temperature, as you vary the compressed air flow from either end, you also affect the temperature drop. So if it's not performing as expected, check for back pressure. Another thing to check for is the distance from the vortex tube to point of use. When you set a vortex tube to create a certain temperature drop or a certain cold temperature at the cold end, that's the temperature just inside the exit of the vortex tube. Once that cold air starts to flow out and you're in a relatively warm environment or hot environment, you're going to start conducting that heat from the hot air, from the surrounding environment, to the cold air that's being delivered. It's going to start to warm up. So if you have too long a delivery tube to where you're actually using it, it's going to warm up that cold air. So, for example, if we do tool cooling, if we're cooling a tool bed in a dry machining application, we try to limit the flexible hose that delivers the cold air to the tool to about 6 inches. If it starts getting longer, you have two effects. You have that conduction from the outside air, warming up the cold air, and of course, the longer the tube, you start creating a back pressure. So if it's not quite performing as you expect, check to see if the delivery tube for the cold air is too long. Another thing to check, what happens if the the compressed air temperature falls below the dew point? Your compressed air supply, say, has a dew point of -10 degrees Celsius. As that compressed air goes in there and goes into the vortex tube, and that air is falling to, say, -20, if the dew point's only -10 and you want -20 coming out, you could get freezing on the inside of the vortex tube. If it freezes, it's going to stop working. What's funny is that it'll freeze, then thaw, spit out some ice, start up again, and then freeze again. It's kind of funny to watch, but it's not so funny if it's affecting your operation. So you have to be very careful to make sure that, depending on the compressed air temperature or the temperature that you want coming out of the vortex tube, your dew point of the supply compressed air is lower than the temperature you want coming out of the vortex tube. So check your dew point. Leakage. If the vortex tube is not tightly put together, let me take it apart and show you. This is the generator that makes everything work. When the compressed air comes into the vortex tube, the generator makes the compressed air spin. That generator has to sit very tightly against the surface inside that vortex tube. And then the cover has to be very, very tight, holding everything tightly together. If there's a leak, that air is not going to spin, or is not going to spin properly. If it doesn't spin properly, it doesn't create the vortex tube effect, and it will not work. So make sure that if for some reason your vortex tube is not working, check for possible leaks because something is not tight in the assembly. And finally, check your supply pressure and your flow. If you have a vortex tube that utilizes 40 CFM at 80 psi supply pressure, but you don't have 40 CFM, or you don't have that supply pressure, or perhaps there's pressure drops in delivering that compressed air and you're losing a lot of pressure, that's going to affect the performance. So check your air supply. Check that you have enough flow, and check that you have enough pressure going to the vortex tube. So, in summary, if your vortex tube is not working properly, check back pressure. Check the distance from the vortex tube from the point of use from the cold end. Check the dew point of your compressed air supply. Check for any leakage, and make sure that your supply line has adequate pressure and flow. If you have any questions concerning the use of compressed air for blow-off, cooling, drying, moving, ask less.